Welcome to Graphing Rationals Day 2. Because rational functions behave so badly, we have come up with a 5-step method to help you graph them more accurately. We call this method RADI. We're going to go through each step of the process, and then we're going to practice a few of those so that you can see how RADI works. I would like to introduce Desmos into this scenario so that you guys can use Desmos as a way to confirm what it is you're doing while you're trying to learn the method called RADI. All right, RADI is an acronym which stands for several things. All right, R is your roots. The roots are going to be located at the top of your problem, or the top of your fraction. You're going to set the top equal to 0. You're going to solve for x, and you're going to place those dots, those roots, at each point on the x-axis where they occur. Now, the reason why this is effective is that we can give you a step-by-step process to help you get parts of these problems correct, and hopefully that will help you get some idea and some linking between each part of this graph. Our next part of the acronym stands for asymptotes. Asymptotes, specifically vertical asymptotes, because we're setting the bottom of the fraction equal to 0 and solving for x. We'll be drawing vertical lines through each one of those solutions when we find them. T tends to be a little bit confusing, so we'll spend just a moment on it to make sure we understand what we're looking at. All right. T stands for tangency or togetherness. This is the behavior of the graph around roots or vertical asymptotes. We've got to look carefully at where the tangency or togetherness occurs so that we know which one is which. So until you really get this down, it's just going to be referring to your notes frequently to making sure that you make the connections to what you're looking at here. Okay? So we're looking for multiplicities of 2. When we look for multiplicities of 2, we're looking for things like perfect squares. Okay? Perfect squares would be x squared. It would be a perfect square trinomial such as x plus 2 quantity squared. Okay? Those are some examples of perfect squares. If you have a perfect square which is found on top, then you have what is called tangency. The graph will touch a root and then turn around much like a parabola will. The shape of your graph will have a parabola shape in the middle of it at some point. If you have a multiplicity of 2 found on the bottom of your fraction, then you have something called togetherness. The graph will have the same behavior on each side of the vertical asymptote. That means that if the graph goes in the positive direction on one side, then on the other side it will also go in the positive direction. Okay? So let's go ahead and write down some multiplicities of 2 so that you guys have some ideas in your mind about what a multiplicity of 2 looks like. As I had mentioned just a moment ago, x squared is a multiplicity of 2. A perfect square trinomial such as x plus 2 squared is also a multiplicity of 2. All right? Let's look at some bad examples of a multiplicity of 2. 2x to the third is obviously not a multiplicity of 2. That's a multiplicity of 3. And then x squared plus 2 is not a multiplicity of 2 either. Even though you have a perfect square here, you actually have this plus sign with the little 2 tagging along. So we'll go ahead and mark through these 2 to remind ourselves that those are not multiplicity of 2. Now, if you have tangency, tangency means that when you see a root on your graph, I'll draw a little sketch right here, and the root is located there between 2 asymptotes. There'll be an asymptote on this side and an asymptote on this side. The graph will do this and have this kind of behavior right here, where you have a parabola on the inside, rather than going through the root and continuing down towards negative infinity. If you have something called togetherness, than if we have that same graph going on right here, and I have an asymptote here in the middle. Togetherness means that on one side of the vertical asymptote, if the graph goes up, then the other side of the vertical asymptote, the graph will also go up to positive infinity. Likewise, if one side is going to negative infinity, then the other side is also. If there is no multiplicity of 2, then you mark t as none. So this is something that you're always going to mark. It's either going to be tangent, together, or it will have none. So just keep that in mind when we get to t. All right, E, end behavior has some things to look at also, so we're going to focus on that for just a few minutes before moving on. So let's look at it here. Okay, we're going to look for the highest degree. That's the largest exponent. If the largest exponent is found on top, we're going to use the acronym BOTN, BOTN. That means bigger on top. There is no horizontal asymptote. Okay? If it is found on the bottom, we have BOBO, B-O-B-O, bigger on bottom, y equals 0. If they're the same, then we're going to use SYAB, same, y equals a divided by b, where both a and b are the leading coefficients of the top and the bottom polynomials. And we'll keep that in the back of our mind in just a few minutes also. When you draw a horizontal line through that solution, whatever solution you get, whether it's 0, whether it's a divided by b. Now, with bigger on top, we have something extra special that we've got to deal with, which is why we spent so much time with long and synthetic division. So if it's bigger on top, we're going to have to do long division to find the oblique asymptote. Long division to find the oblique asymptote, or slant asymptote. All right, so leading coefficients are, and we'll do a leading coefficient of the top, and b, leading coefficient of the bottom. That was basically the first number you see on the top and bottom of your fraction. All right, and finally we have y. That's going to be your y-intercept. We're basically going to solve for y when every x equals 0. Okay. Enough with our notes. Now let's have some practice. Okay, when you're doing the Rady method, you're going to see your Rady boxes, so we're going to be able to fill in each part as we go. The first thing I want to do is I want to set the top equal to 0. 4x minus 12 equals 0. It's kind of like a puzzle. We're going to put all the puzzle pieces together, and then hopefully everything fits into place. So we get 4x equals 12, so then x equals 3. I'm going to come over here and put a dot there. That's my root, okay? A, set the bottom equal to 0. X minus 1 equals 0. So x equals 1. A, put a vertical asymptote at x equals 1. T, tangency or togetherness. Tangency or togetherness. I'm looking for a multiplicity of 2. Well, there's no squared terms anywhere, so there are no multiplicities of 2. So I'll mark this as none. E, end behavior. I'm looking for the highest degree. That means I've got a 1 on the x here and a 1 on the x here. S, Y, A, B. That's going to be y equals A over B. A is the leading coefficient of the top, 4. B is the leading coefficient of the bottom, 1. So that means my y-intercept is at y equals 4 over 1, which is 4. Place a horizontal line through that solution there. All right. My y-intercept is found by setting all of my x's equal to 0. So y equals 4 times 0 minus 12 divided by 0 minus 1. So y equals 4 minus, or 0 minus 12, which is negative 12. 0 minus 1, which is negative 1. So y equals 12. So I put a dot here at that solution. Now I've got the puzzle pieces in place. I know that the graph is going to reside either in this spot right here or in this spot right here. You can see by the columns here and here that the graph will be either on the top part of the column or the bottom part of the column. So I'm looking for clues to help me determine where it is. The axis is my clue. If there is a dot anywhere along this axis in this column, I know that this graph is going to pass through that dot and follow the asymptotes like it's supposed to. If there is togetherness, then I know that the graph will pass through the other side, moving down here. So that's my first clue to determine whether or not this side or this side of my other column is being occupied. My second clue is the other dot, my y-intercept. I know that the graph must pass through these places. Why? Because they are defined values that I just found using the Rady method. The graph must pass through the y-intercept. The graph must pass through the x-intercept. These are values that I have found, and they are defined inside of the graph. Since they are, they must be places where the graph is located. So these are clues to help me understand where to graph this thing as I'm going along. Okay? Let's practice one more time before I let you guys go on the rest of your work and see if you guys can figure it out. Okay, so the next thing I'm going to do is I'm going to look at the top root. That's 3x squared plus x equals 0. I'm going to factor out my GCF to make it easier for me to solve. And I get 3x plus 1. Now I'm going to set both of those equal to 0. And my first answer is x equals 0. And my second answer is x equals negative 1/3. Now that I do that, I'm going to put those two on the graph. I'm going to zoom in a little bit here so that it makes it easier for me to graph these things since they're so close to each other. Okay, so this one's going to be at 0, and then this one's going to be at negative 1/3. This zoom is going to be important for me, so I'm going to come back to that in just a second. Okay, my a, that's going to be the bottom, so that's x squared minus 9 equals 0. Again, I'm going to factor x minus 3, x plus 3 equals 0. And that makes it very easy for me to solve my vertical asymptotes of x equals 3 and x equals negative 3. Back to the graph, and let's put our vertical asymptotes in place. Now before I go on any further, we can clearly see that the graph is going to be located in this middle zone somewhere. We've got to figure out where and how by filling in the rest of our clues. But because these 2 points exist, there is going to be a graph in this middle zone somewhere. T, looking for multiplicities. All right, so I've got a squared on top and a squared on bottom, but because I factored this one and those are 2 different numbers, that is not a multiplicity of 2, even though it's really close, so don't get confused there. Again, I factored this one and that's not the same value written twice, so that is also not a multiplicity of 2. So the answer here is again none. E represents my end behavior. I'm looking for the highest degree on top, which is 2, highest degree on bottom, so that's S, Y, A, B. That's going to be y equals a divided by b. My number on top is 3. My number on bottom is 1. So I'm going to put a horizontal asymptote at 3. And there we go. Now my graph is set except for one very important piece, and that's going to be 3 times 0 plus 0 divided by 0 minus 9. 0 divided by 9 is 0, so my y-intercept is the ordered pair, 0, 0. Boom, already there. All right, now I'm going to zoom back in on my graph here. Let's go to 200 so I can, there we go. And now we need to look at all of our pieces. I'm going to go to the place where the graph exists at first. I know that it exists in this center column right here in this bottom portion of the column. I know that it's not going to cross this asymptote, all right? So that means that the graph is going to go up through one root and then back down through the other. So even though this has a parabola shape, it is not for the reason that I mentioned at the beginning of the notes. It just goes up through one of the roots, back down through the other root, and then continues on down through here, okay? I'm looking along this part of the x-axis for any signs that the graph goes through there. Well, if it's going to pass through like this, there would be a root at one of those locations, and there's not. So I know for a fact that the graph goes here. Well, I know for a fact because I've done it before. I have a pretty good hunch, if I've never done this before, that it passes through there. I also know that there's no togetherness, so that means that this graph will not behave around this vertical asymptote by moving down. Why? Because we labeled t as none. For the same reasons, the graph is going to be here, okay? No togetherness and no roots that pass through this part of the x-axis. Now you're going to find this strategy to be a little bit confusing at first, but it is important that you stick to the methods and stick to the steps until you get familiar, okay? So what I want you to do right now is I want you to practice the remaining two problems on your own. That's this one and then this one. And we will come and discuss these at the beginning of class tomorrow. And please make sure that you write down any questions that you might have, knowing that there will be a few. I want to go through them carefully and be able to clear up any problems that you may have while you're working through this new method of solving or graphing rational functions.